All right, boys and girls, welcome to your first day of learning online, fun stuff. We are going to be going over our lesson, first lesson from Unit 2, called Sketchy Dilations. It might be called Exploring Dilations and Similarity. Again, it'll be the first thing on uh, your dashboard on Desmos. Okay, so get that going. Um, we are going to be, it's kind of going to be weird where I'm going to be asking you to follow along with the video that I have, as well as the things that are on um, our site here. Okay, so if you need to pause the Wii video, go for it at any time. You will be working on this at your pace. Okay, so let's see here. All right, I'm going to go to our lesson dashboard and work through uh, this lesson. Okay. All right. So for our warm up, you have 4 different machines you are going to play around with. All right. So go to your dashboard. You can pause the video as you go over there, but make sure you work with all 4 of these machines. So if you want to see me working with these, you can as well. So this first machine does like this. Makes these like stripes. Okay. Second machine. Oh, the dot's in a different spot. Oh, but these are like closer together than they are from the dots. Or the middle dot. Oh, now they're getting closer. And then they get further away. All right, third machine. Oh, the dot's over there, but now I'm in control of a different dot. And machine 4. Oh, the dots are on different sides. Just going to make a circle. Oh, it's kind of like a target. Well, and the dot's on the opposite side. Okay. So once you've played around with that, you can move on to the next page. Well, actually, let's describe these first. All right, so machine 1, I'm noticing that this middle dot here that I'm on is half the distance to the dot that's not moving and the furthest dot. It's right in between. Second machine here, that's not exactly in the middle. It's a little bit further. This third machine, I'm controlling the furthest one, but it looks like that dot that's not drawing for me is halfway between. And this one, it looks like that smaller dot or that smaller line is halfway between. Let's see. But it's on the opposite side. Yeah, it's like halfway between, but doing it on the opposite side. All right, let's go to the next page. Okay, so this says trace the shape. Okay, so I'm just going to go over here. All right, I'm going to trace this shape. See what happens. All right, you can do this yourself as well if you want to do it. Pause the video and trace it yourself. You're going to have to answer, so you're going to have to pause the video anyway. Okay, it says, how would the image be different if point A were closer to the triangle? So point A were closer to the triangle. I'm going to do this. Look at this. It's terrible, but it's okay. It works. Ooh, it's kind of like one of those like 3D things. It's like getting smaller and smaller and smaller. Ooh, let's do this. Whoa. It's like an infinity. It like keeps going. Infinite. So it gets smaller and smaller until we can't recognize it. So how would the image be different if point A were closer to the triangle? Well, if I go further away, my triangle gets further away. So we'll go over that question here afterwards. So this says a dilation is a new type of transformation that you have been exploring in this activity. So yeah, we're dilating. We're getting bigger and smaller. Oh man, let me go back. Let me erase this. Just trace this one time. Okay, let me go back to this next one. It says a dilation is a new type of transformation. So we have this dilation, and look, as I get further away from my shape with A, the other shape down here gets further away. So this middle shape isn't changing anywhere. But if I get closer, then that other drawn picture gets closer. Does moving point A change the size of the image? Is it getting bigger or smaller? Is my image getting bigger or smaller? I think it's just, let's see. If I get closer, further, what does it do? Does it change the size, location, or both? Pretty sure it's just a location, right? I mean, I'm noticing that as I move this around, it's the same size. So the size is staying the same, but the location of the new shape is moving in relation to point A. The new shape is, let's just say that for now. Yeah, I mean, that's interesting. Look, all right, so point A to here, it's like it's halfway in between. Okay, what if I move it here? Oh, notice this point to A, this point's right in between. Okay, so it's like 2 times. Let's see what they have us doing next. Okay, broken dilation. The stretching machine you have been using in this activity creates dilations. Choose one image that could not have been created by tracing an image with the stretching machine. So which one looks odd to you? Which ones look weird? I mean, if I look at this one, this is a rectangle. This looks like a rectangle, just it's like 2 times the size. If I look here, I have a square. And then it turns into a rectangle. That looks like it's not the same type of shape. This one here, we have a pentagon. And now I have a 1, 2, 3, 4. Now this is 6-sided. I don't think we can go 5-sided to a 6-sided. And then this one, we have a rectangle. And now that's like off a little bit. So explain your thinking for each of these here, and then we'll go over that here at the end. You can pause the video now and then write down your answer. All right, so ready for more? I am ready. All right, move points A and C. So if I move C, oh, look at this. It's right there. Ooh, okay, what's happening? Not quite sure. Oh, well, this moves that shape. So moving A moves my shape. I'm noticing moving C just moves that shape. So here are several challenges which are possible. Make the image smaller than the pre-image. Can I do that? Ooh, it looks like I can. So remember pre-image, this is what we started with. So yeah, we can make it smaller. All right, make the image the same size as the pre-image, but in a different location. So here, no, it's not doing anything. Can I do that? Let's see. I don't think I can do that. It's going to be bigger. It's not the same size. It's a little bit bigger, so I can't do that. Make the distance between A and B twice the distance between B and C. Yeah, I can do that. So there's B and C there. And I'd say that's about twice the distance as that. So I can do that. Make points A, B, and C form a triangle. Can A, B, and C form a triangle? No, it looks like A, B, and C all have to stay on that same line. So it doesn't make a triangle. So that doesn't work. So it's just these 1 and 3. All right, similar figures. Dilations make figures that are scaled copies of the pre-image. So they're like, the way that the word scale means, it means all sides are multiplied by the same amount. So if I want something to be 2 times the size, then if I do this square, if I want it to be 2 times the size, well then, all right. If I want it to be 2 times the size, then I would go 2 times out, 2 times further out. Oh, that's messed up. Go back. So I go 2 times as big. So I would multiply both of all these sides by 2. All right. So let's see. Let's go back here. It says dilations make figures that are scaled copies of the pre-image. We also call these scaled copies similar figures. So they're not congruent anymore. They're similar because, like, you have a small car or the actual car. They aren't congruent where they can match up exactly, but they are similar because one's smaller than the other. So what do you think it means for 2 figures to be similar? So these are similar. These red shapes are similar, but these purple or blue shapes are not similar. So what do you think it means? We'll go over that here at the end. So you can pause the video and write your answer. When you're finished, press play. Okay, here it says, which are similar? Click on the figures that you think are similar to figure A. So figure A, which ones? Oh, does this one look like it? Figure A has a flat side here. Does this have a flat side? No, so that is not. How about this one? This just looks like a bigger version. So I'd say that. This one, it looks like the same shape. However, are all sides different? It looks like it just got taller, but then it got skinnier. It's like it got tall and skinny. So that wouldn't be a dilation because it's doing like 2 different things. Whereas here, it's like stretching it in all directions. It's making it bigger in all directions. This one looks similar because it's just mirrored. It's just reflected. But it looks like every side got a little bit smaller than A. So I'm going to say these two. And I'm not just going to say it's these two. It is, or yeah, that's the answer. These two, this isn't the same shape at all. This is a similar shape. However, like I said, it's stretched and squished. It's not like stretched and stretched like this one, or made smaller and made smaller like this one. All right, here are three figures. Two are similar and one is not. Explain which figures you think are similar and how you know. All right, so using what we did back here, those kind of reasons that I just brought up to you, what figures are similar? And we'll come back to this here after our slides. So please pause right now, type in your answer, and then press play when you are finished with your answer. Okay, cool down here. We are clicking on the figures that you think are similar to figure A. Which ones are similar to figure A? Remember, we have to squish or stretch, or we need to make it bigger or make it smaller on all sides. It's not just one thing. Does this shape look anything like A? No. Does this shape look anything like A? Absolutely. However, it's the same height. It's just as tall as A, but it's longer. So notice that one side hasn't been changed in shape or in how big it is. It's actually stayed the same, but this has gotten bigger. So that can't be. And then this one, yeah, it looks like it's just everything got bigger. And this one looks like everything got smaller. So I'm going to say those two. All right, and you're welcome to answer these. But once you're finished, let's see. Once you're finished with these, then we will go back through. I'll give you a few more minutes to go back through these. If you went through this quicker than others and were waiting, just hang tight. We will go over this here in a moment. All right. And then I will be assigning you practice problems on here after our conversation. All right. So maybe go back through these slides. If you didn't type in what you needed to, go back and type those answers in. All right. And then we'll meet back as a group here in a moment.